Yo, what up? Fourth period. It is snowing like crazy right now, which is insane. And I'm about to, this is right before we have class. But this video has one purpose, and that is to get you better at quadratics for our test that's coming up Friday. You heard it. If you didn't hear me say it in class, test Friday. Boom. So that means we have today, well, you already had, by the time you're watching this video, you already had class today. We did word problems today on the calculator. This video covers everything. Tomorrow, we review a few key solving methods, and then block day, we get after it with a little practice test action and just try to make sure we're ready, okay? But I want to show you something. I'm giving you a little freebie here. Here's the test. At the top of the test, see, there's problem 1 and 2. At the top of the test, I put the objectives that we need to cover. And what I'm going to do in this video is rapid fire cover some of these main ones, and then actually even solve some problems on Khan Academy that will help us. But if you pause the video right now, you should look at A through I and rank. How many are there? 2, 4, 6, 8. There are 9 of those. You should put those in order from top to bottom of what you feel most confident in and what you feel least confident in. And that is then what you can emphasize on and ask me questions about on Tuesday and Thursday. Please ask me questions. Please come in the morning and let's do some problems. Like whatever you need, I got you. But you got to meet me halfway. All right? So let's snip this. Control C, Control V, bang. Look at that. Shout out to modern technology. Okay. So identifying quadratic, linear, and constant term. I'm thinking we're okay with that. If you need help, let me know. Finding the vertex, axis of symmetry, y-intercept with no calculator. That's pretty key. And then like these kind of go together. If you can find the vertex, axis of symmetry, y-intercept, etc., then you can graph it. Okay? So just a quick reminder, the way that first we need to know what the parts are. I'm really hoping that at this point you understand that this is the vertex and that the vertex is an x and a y coordinate. It's a point, okay? This is these two things here are the x-intercepts. Both of those are x-intercepts, and those are always a number, comma, 0. So this might be 7, 0, this might be 1, 0. Okay, those are x-intercepts. And then the last piece is this right here. I needed to go a little farther. Let's go down like that, because then I can clearly put this right there. That is the y-intercept. And that is always 0 and then a number. So like 0, -2. Those are the main pieces that we need. And then all tied together with this. The axis of symmetry slices the parabola directly in half and is always an x equals equation. X equals 3 in this case. I'm just making this up. Let's make up a vertex. Let's say this is 3, 4. Okay. So how do you find these algebraically? Well, to find the vertex, just a refresher, and then we'll jump over to Khan Academy. You do b over -2a, and then whatever you get, you plug it back into the equation to get your y value. Once you know the vertex, the axis of symmetry is just x equals whatever that is. And then the y-intercept is always the c value, right? So once you have those pieces, you are ready to graph and reflect. If you want to try one, pause the video right here and retry this one on the quiz that almost all of us missed. Try this one. Find your vertex, find your axis of symmetry, find your y-intercept, and then make it happen on the graph, okay, using this equation right there. Pause the video and try that if you want. All right, back to review. solving quadratics by factoring, that's where you use the zero product property. Like if you have x squared minus 6x equals 7, the first step that I have to do is set equal to 0. We always forget that. So I need to move that 7 over so that I have this. Okay? And now I'm able to factor, and then I'm able to use the zero product property. What do I mean by factor? I mean, in this case, use one of our methods to split it up into its two factors. This one becomes x minus 7 and x plus 1. Those are the factors that can multiply to give me negative 7 and combine to give me negative 6. And then I use the zero product property to set this equal to 0 and solve my first answer, and set this equal to 0 and solve to get my second answer. Okay? That is called solving by factoring. I just found my two x-intercepts. Okay, that's what you find when you solve. Any of these over here that say solve, finding the x, finding the x, finding the x, finding the x. Okay? Square root method is where you're left with like x squared equals 64, and then you square root both sides and you get plus or minus. You still get two answers. That's the square root method. Quadratic formula. Remember we played the Pop Goes the Weasel song? X equals, quadratic formula is negative b plus or minus the square root of b squared minus 4ac all over 2a. Or, remember this way? There was a negative boy. He was unsure about a radical party because he was a square. He missed out on 4 awesome chicks, and then he did walk out of there with 2 apples. I think that's what we made up or something like that. But anyways, that's quadratic formula. Okay, so that's a really quick review. We did this stuff today in class, so I'm not going to go over the real world problems, but I want to finish with some Khan Academy styles. Okay, we have 5 minutes, 6 minutes to do it. Let's go and take a look. All right, what we got here? Okay. Ali and Akari were trying to solve the equation, and that is the equation. X minus 1 times x minus 7 equals 5. Ali said, I'll multiply these two together and rewrite the equation as x squared minus 8x plus 7 equals 5. Then I'll subtract 5 from both sides and use the quadratic formula where a is 1, b is negative 8, and c is 2. That sounds pretty good to me, honestly. But let's see what Akari said. She said that the left-hand side is already factored, so why don't we just use the zero product property? That's a great question too. But what's the property called? The zero product property. These two factors are not set equal to 0. They're set equal to 5. So Akari's would not work. Ali's would work. It's factored out. He could multiply it and then set it equal to 0 and use the quadratic formula. Only Ali's method is correct. Okay, let me turn my volume up. I want to hear this. Bang. Okay, let's keep going. I love these questions. Lucas and Tony are trying to solve this equation. Okay, look at it, everybody. This is perfect. This is just like the test where it doesn't tell you exactly what form to use. You have to figure out what form you want to use. X squared equals 16x plus 25. Lucas says that the x squared term is isolated, so I'll take the square root of both sides and solve. Tony says, I'm going to solve using the quadratic formula. I'm going to make my a be 1, my b be 16, and my c 25. Which strategy would work? Well, this is a perfect question. It's almost like Khan knows what they're doing. Let me tell you a couple things. Because the x squared is isolated, that might be my reaction too, but we cannot square root the right side of that because there's that linear term. Okay, this right here is a linear term. Here's your constant term, and here's your quadratic term. Okay, that's great. We can square the quadratic, and we would have been able to square that, but you cannot square root a linear term. So the square root method is out. Tony said he would solve it using quadratic formula, which works all the time. And he said that his A was 1, his B was 16, and his C was 25. Well, we got one big problem, Tony. You didn't set it equal to 0 first. If we set it equal to 0, look what happens to B and C. It's negative 16 and negative 25. So Tony's is out as well. He didn't set it equal to 0, so I don't think either of theirs works. Neither work. Bang. Let's do a couple more. Okay. Carla and Jordan are trying to solve now. X plus 1 times x minus 1 equals 8. So Carla said, I'm going to multiply x plus 1, x minus 1. So she's going to multiply, rewrite the equation as this, add 1 to both sides, then square root. Not bad, Carla. Jordan says, since the left side is factored, I'll use the zero product property. Our guy Jordan has been working with Akari from earlier. You cannot do the zero product property if that number right there is not a 0. So I think Carla's work? This FOIL out x squared minus 1. Yeah, that turns into that. Then she's going to add 1 over to get 9 square root. Yeah, Carla's got it. Boom. I see you, Carla. Okay. All right. Diego and Amit were trying to solve the equation. This is our last one here. Try to solve this on your own. Pause the video right now. Take 60 seconds. See what you got. Pause it. And now we're back. Diego said that he's going to complete the square. We haven't done completing the square yet. I didn't know if I wanted to teach it to us or not. I decided for us not to. So I'm actually going to skip this problem. Sorry. You probably started solving this and we're like, completing the square, what? It's just another method. I think that's going to work. And honestly, let's see if Amit's works. Subtract 1, so he moves the 1 over. And then he's going to rewrite it as this, correct. Then he wants to use the quadratic formula. A's 1, yep. B's negative 8, yep. C's negative 1. Yeah, so Amit's is going to work. So believe it or not, they're both going to work. And so we'll go with both. Sorry about the not telling you completing the square stuff, okay? So that's going to be helpful for you. I think there's one more thing that I want to make sure you can do. And it's this. Yeah, this is our last problem, okay? I want you to be able to solve these on the calculator. I'm gonna let you solve these on the calculator, okay? What are the zeros of the function? I just want you to remember, zeros are another name for x-intercepts. So anytime they ask you for the zeros of a function, they're talking about this and this. Those are the zeros, okay? So they want to know what the smaller one is and the bigger one. And then they ask for the vertex. So let's type this into our calculator real quick. Negative rx, anytime there's a variable, just use x. So negative x plus 9 squared. I'm going to have to hurry. Negative x plus 9 squared plus 36. I'm going to hit zoom 6. Whenever I'm not sure if I've been zooming in or out, zoom 6 is a good way to start it. Whoops, I forgot the square, didn't I? No, I got it. Okay, that looks weird. Why the heck does it look like that? Oh, maybe because we can only see a little sliver of it. So if you ever need to change your zoom, I'm going to hit window, and I'm going to change all these to negative 20s. Negative 20 minimum, maximum of 20. Maybe I need to go up too. So let's go y maximum up to 20. Let's see what this looks like. Hey, a lot closer. I need to obviously make my y-axis go higher. So I push window, and instead of my y-axis stopping at 20, let's stop it at 40. And now I should be able to find both my vertex and this x-intercept and this one. And then I'll plug them in. And we talked about calculator stuff today, so I hope that helps. We'll do these con assignments later in the week. I just think it is a great teaching point for me. So remember, study these things, rank them, and if you feel great about those, you should feel great for the test. Have a wonderful day.